Hey guys, today we're gonna learn how to create a payload using Hercules framework, and that's gonna be used to bypass the antivirus which are installed on your endpoints. So I'm running a Windows 7 system, and the antivirus that I have is System Center Endpoint Protection. So I have a x64 architecture system. It's a 64-bit Windows 7 platform. So for creating a payload using Hercules, you need to have Kali Linux, and you have to install Hercules framework. So the framework for Hercules, you can directly get it from GitHub, and you can just clone it or your Kali Linux and run from here. So I'm not gonna create or install Hercules again, that because I've already installed it. So I'm just gonna run it because I'm sure you guys know how to install a framework directly from GitHub, how to clone a GitHub framework on your Linux systems. As I said, you need a Kali Linux Hercules framework, and I'm using this test folder which I've created in system C, where I'm gonna dump my payload file and execute it from here. So let's get going. So to execute Hercules, you don't have to do anything. Wherever you have installed it, doesn't matter. You just have to write Hercules, and it's gonna fire the framework options. So if I run it, I get Hercules. So it's right now in this version, which is 3.0.5, it's giving me three options: generate the payload, bind the payload, and update Hercules. As far as I know, in this particular version, the bind payload option is not available, and they're gonna bring it in probably next version, and that's the error you get when you select option 2, update, to update the framework. If you're using an older version, you can use this option to upgrade to the latest version of Hercules framework. So in this exercise, we're just gonna use the option 1, which is generate payload. So I'm gonna use option 1. Okay, so it gives me 4 options. The metapredator reverse TCP, metapredator reverse HTTP, reverse HTTPS, and reverse shell. So all of these payloads have some AV evasion score. So it just gives a score out of 10, which is actually an indicator how your particular payload is able to detect, evade from getting detected by your antivirus solution. So more the score, more chances is that your payload will not get detected by your antivirus. So if you see metapredator reverse TCP is giving me a score of 8, reverse HTTP 8, reverse HTTPS 8, and reverse shell of 7. And this is just a standard size of the payload which it creates. So starting from 946 to 4.4 MB. What we are going to do is we are trying to use Hercules reverse shell, because here it says the least score of AV evasion. We're going to see if this is also getting detected by antivirus or not. Right now we are not much concerned about the size of the file, but if you're concerned over the size of the file, you want to keep it as less as possible, you can try to create reverse TCP connection, or you can compress it using UPX or whatever format you want to compress it. But right now I'm not concerned about the size. I just want to see if the least possible evasion score payload is getting detected by antivirus or not. Okay, so I'm gonna select option 4. So it gives me a couple of options. First you have to enter the lhost, which is the attacker machine. So in my case it's 192.168.56.101, and then you have to specify the port on which you actually want to listen, the connection coming from the victim machine. So I'm gonna use any high numbered port to ensure that that particular port is not being used by some other service. So I'm just gonna use, let's say, 11111, a high numbered port. Okay, so it asks me what's the base name for the output file. Okay, I can give any name that I want. Let's say dom1.exe. No, dom1. Okay, it's just gonna append exe on its own. So do you want to compress the payload? If you are really concerned about the size, you can compress it. I'm not concerned about the size, so I'm just gonna hit no. Okay, So it just created a file named dump1.exe. It's saves in my current directory where I ran this file. So you can see dump1.exe. So that's the executable it has created. I'm gonna send this file to my test folder directory, which I created here. I'm just gonna dump it here. Put dump. Okay, that's a incorrect folder. Where did we dump that file? I think it was okay, it was in root. Okay, so I'm gonna just go to root and dump1.exe, and I'm gonna save it as again the same name, dump1.exe. So my file is sent and it should be here now. Okay, so there you go. So the file is created. It has created a size of around 3.2 MB. Okay, and if you see these payloads, if I run a custom scan on my test folder directory, so already selected, if I run scan, okay, it says scan completed. It doesn't identify it as a malware or any file which is not a true file or something which is not malicious. So it just flags it as a clean file. So there we go. The payload that we created using Hercules is not getting detected by antivirus, so it's actually evading it. So this is just the first two things. So it has bypassed signature based detection, so there's no signature available, so we bypass signature, and we also evade heuristic because we have a file here, but as per the heuristic engine, it's not marking it as a malicious file. So even if I change it to, let's say, notepad.exe, it doesn't make any difference. My antivirus still doesn't tags it as a malicious file. So next what we are going to do is to see if it actually tracks it during behavioral analysis, because sometimes antivirus, they just don't clean a file or scan a file which is just residing on your system, and only when you run it and it tries to behave a bit suspiciously, then only it tags it. So the next thing is we are gonna run this file and see if during runtime it identifies it or not. To run this file, we are gonna, because we used a reverse shell payload, we're gonna try to connect to my system, the Windows 7 system, on a shell. We're gonna get access to its shell. So for that, first we have to fire up our MSF console, the MSF Metasploit framework, and then we have a lot of exploits which are available in Metasploit framework that we can use to listen Meterpreter payload which tries to connect to our victim, our attacker system. So the Kali Linux that we have here is actually my attacker system that I've used, from where I'm not trying to take the access of my victim system, which is my Windows 7 system, where I dumped my payload. So I'm gonna use exploit, multi, and handler. Okay, so there you go. So this is the exploit that I'm going to use. First I have to set a payload which I use to create my payload in the first place. So as you know, I used a shell reverse TCP payload, so I'm gonna use Windows x64 is my architecture, shell, and reverse TCP. Reverse TCP. So that's the payload that I'm gonna use. I'm gonna set the lhost IP, which is my attacker IP, and that's in my case is 192.168.6.101, and the port that I specified during creation of the payload, which was 1111. Yep. Okay, so I'm just gonna fire it. So if you see, it started reverse TCP handler, on this IP, which is attacker IP, and on this port. So it's now started listening. Now we have to see if this executable, when we execute it, when it tries to communicate with my attacker system, which is Kali Linux, if my antivirus is actually detecting it or not. Okay, so but make sure before you execute this file you have a listener ready. Okay, so now that my listener is ready, I'm gonna run this file. So I've executed this file. Okay, I can also see in my task manager if this file is running. So okay, you can see notepad.exe is running, and when we go to Kali Linux, there you go. I'm gonna just expand this. So now you can see it was listening, and now a session has been opened. So that's my attacker IP, and that's my victim IP, and it has opened the connection on this particular port. So I can see now I've got access to the shell of my victim system. From here now I can do anything I want. So it's running a system center endpoint protection. It's a Windows system, and I can now run any command that I want. I can dump more exploits on the remote system, which is the victim system. I can create scripts. I can do whatever the shell gives me access to. I can do anything. I can create file, delete file, get access to sensitive files, or I can copy the SAM file from that particular system, and I can bring back to my victim system, check the contents of it, and then I can get the credential of that user. So I can use all those things to, do all sort of nasty stuff which an attacker would definitely do. So as you can see, I can now use my remote system, the attacker system, to run commands. Like if I run a system info, I can see the complete details of the system. I can run through the directories and see what's there in the directories. If there's any confidential data, I can copy that. Okay, so I think yeah. So if you see, yeah, that's a result of system info command that I ran. So I can see the name of everything, complete details of the file. So if you see, even though I ran this file, my antivirus still hasn't detected anything. So it still says your PC is protected. That means the antivirus failed to detect this particular payload in its signature based detection, heuristic based detection, as well as in behavioral based detection. So in this case, I ran it for system center endpoint protection, but you can try testing on your antivirus. You might be using different antivirus, maybe McAfee, Norton, or whatever name you could say, Silence, Sentinel-1, Microsoft ADP. You can try testing all these things on your antivirus solution. So here I conclude the exercise. So we came to know that you can use Hercules framework to actually bypass your antivirus solutions. It also points to the fact that antivirus solution need to do more tweak up of their detection capabilities to see how different payloads which are getting created using MetaPredator framework or different framework which Kali Linux Pentest OS is providing, because right now I did it on my system, but in real-time system, in real life, an attacker will try to do it from your system, and at that time the destruction would be a bit more than what I'll do during testing. So that's all from my side. I hope you like the exercise, and if you have any queries, please write down in the comment section below. And if you want to see anything else, or if you have any queries that you didn't understood during the whole demo process, just write it on the comment and I will revert it as soon as I can. And if you like the video, please like it and subscribe to my channel, and please share it with your friends who want to understand how you can do all this stuff of antivirus evasion, because most of the time we use it during selecting what kind of antivirus that you want to choose for your company or for your personal use. So this is a good way to do all sort of testing. I hope you like the video. See you next time. Bye bye.